Alright guys, welcome back. Uh, Today I'm going to talk about question 7, which is also a good question for the exam or for the quiz. Most of professor like this question. I believe I think probably like 65, yeah, 17, yeah. So it's a very good question and is uh, good to solve, and then it's very easy and very uh, a little bit hard. Okay, so here's a question. I just write it down. You can copy it or you can write it down before we start, or you can take a picture or screenshot. Okay, so before we started, I'm going to show you something about the equation you need to know. So this is an equation that you need to know. In you need to write it down in your paper or in your notebook or in your cheat sheet. Okay, this tau net is equal to this initial. Okay, I is initial effort. It is used for the Pulley problem. Yeah, but it's not only for the Pulley problem, but if you can use for the tau problem. Okay, and also another one is moment of inertia. If the solid ducts, we use I is equal to half mr squared. Hollow winds, not hollow winds, hollow ring, I is equal to mr squared. Solid sphere, I is equal to 2 by 5 mr squared. That you need to keep it in mind before we start, okay? Because we're going to use this. Alright, so I'm going to leave it like this, that way you can see easily beside on the side, okay? So we're going to read the question is a 1.5 kilogram block is connected by a rope across a 50 cm diameter. So this is the block. 1.5 kilogram is connected by a rope. Here the rope across the 50 centimeter diagram. So it's across 50 centimeter diagram. And also the frictional pulley. This is a frictional pulley as shown in the figure. A constant 10 Newton tension is applied to the end of the rope. So this is the end of the rope, they have a tension Newton. So what we need to find is, we need to find a driver relationship for the acceleration of the block in terms of RGI. So what he want including A is equal to including I, G, R. Okay? So RGI is the same. IGR is just the first question. Okay? So I'm going to write here. The first question is what he wants is A is equal to RGI. This is the first question. It's the first thing he wants. The question is asked. And also the B, what is the numerical value of the acceleration? So numerical means with the numbers. So A is, we have to plug in the number, it is meter per second square. It's the same number. That's for the question B. And C is starting from the rest. We can't leave the rest. We need to read the question very carefully. How long does it take the block to move 30 centimeter? So it's mean we need time if the when the block is moved to 30. So block mean like mass is moved to 30 centimeter. Okay, that's we gotta find. So first we draw a picture. It's the same thing. We draw like this, and here's the tension. 1.5 kilogram, and that is 10. That's 10 Newton. So we're going to draw a free body. We're not going to draw a free body diagram because I hope you already know about the free body diagram. Because if you don't know free body diagram, how to draw it, you know, I suggest you have to go back through your lecture or your exercise something. Okay, so here is always have gravity, so that's why it's mg, which is equal to weight. Okay, wg, but we're not gonna write wg. It's always mg. Okay, and here is connected by tension, so that's why it is T. Okay, it's clear, right? Alright, so what I see from the free body diagram, mg, we draw, right, mg minus t is equal to ma. So that's the equation we got from the picture. So how we know it? Very easy. So this is the block, right? The block is moving down from, because the tension is connected the block, but the block is going down. So that's why we just try to count. If you know about the free body diagram, this is very easy. So mg minus t, that's why which is going down, that's why it's minus. So mg minus t is, which is always equal to ma, is the lower of f equal to that's in Newton. So force is, force is equal to mg minus t. So and also ma is ma. So that's what we got from equation. And then what we want is, we don't want to leave like this. We want to get t. So we just write ma minus mg. So t is equal to mg minus ma, equation 1. Okay, it's very easy. I just move t, I just move mg, I just move this mg to this size. So if it's this one is plus, so this one is going minus, and the t is leave like this, and I don't want a negative sign from the t, that's why this negative sign going this way, but I change my mg because I also don't want to see the negative sign in the front of the equation. So that's why I write it, this one is plus because this one is going in this track. So it is mg minus, this is going plus, so this is minus. So that's why mg minus ma is equal to equation 1. That's what we got from by seeing the picture. So this is for the mass. Okay, this is for the mass. So now we're gonna see from the pulley. This is for the pulley. This is the pulley. Okay. So what we see from the pulley is we use the torque equation. Okay. So torque equation is, I already told here, tau net is initial effort. So So we just copy it. And tallness is initial effort. Okay, so what is tallness? So tallness is always T1 plus T2 is equal to initial effort. That's the tallness. Okay, it's very clear, nothing no trick. So then we're going to change T is equal to RT minus R10 is I effort. This might be a little bit tricky. I'm gonna show you very easily. So tallnet is how come the torque is going to RT. It's very easy. That's also kind of like a equation that you have to keep in mind. So this side is T1. It's always half rotation. That's why RT. This one is T1. But from this side is there is no mass. It's only tension, the Newton. That's why R10. We write R10. Initial effort is we just leave it like initial effort. Okay. And also so there's and also we're going to change the effort. So effort is RT minus R10 is equal to initial E by R. Okay, this effort is equal to E by R. I already write it down in my cheat sheet. So what we need to find here is we need to find T, because I just find T here. If I find T, we can combine together the equation, right? So that's why what we can do is we just attract R, because they have 2R. So we attract RT minus 10 is I E by R. Okay, so if I don't want the R in this size because they have another R2, so I'm gonna move this side because I want to find T, right? So T minus 10 is I E by. So then we need to find T. So T is equal to I E by R squared plus 10, which is equation 2. So we're going to combine it T. So by equation 1 and 2, so mg minus me is equal to I E by R squared plus 10. Okay. So what we need to do is we need to find air. The first this question is we need to find air with RGI. So what we see, the A is here. There's a 1A. Here's there's another 1A. So we need to combine A together. Okay. So what I'm gonna do is mg minus 10 is I'm going to move this side A. So I E by R squared plus MA is very clear. Okay, so there has a AA, so we could find A here. So we just track A. So it's gonna be like if I by R squared plus okay, because this, if I attract A, this A is chained to 1, so I into 1 is I, right? That's why I write it I here. Okay, so we're gonna move this side. We need to find A, so we're gonna move this side. It's going to divide it. So mg minus a is equal to I r squared plus m. Okay, so now we finished the question 1, because he wanted to find the drive relationship for the acceleration of the block in terms of rgi of the pulley. So we got I, G, R. We got 3. Okay, so now we finish A here. Okay, then we need to find what is the numerical value of acceleration. We need to find A with the numbers, which is very easy. We just plug in the numbers. Okay, what we see from here is m. This m belongs to here. This m is 1.5 kg. So 1.5 g is gravitational force of Earth is 9.8 minus 10. So I, what is I mean? To find the initial, I is equal to half mr squared. Okay, so half is, if I divide it to half, so half of 1 by 2, right? So 2 into 1. So this is 0, this is 0.5. So we don't want the half with here is going to be, a little bit complicated. That's why we just change it this with a point. 0.5 m r squared. So this is r squared plus m. So then we can cancel off r squared, right? So now we got a is equal to, if you solve this, use the calculator. So 1.5 into 9.8 is 14.7 minus 10, so 0.5 m. How are we gonna find m? This is very easy. The m, this m is right here. That's a 2.0 kg. This n belongs to this kg because this is with the frictionless pulley. Because we're going to find the pulley for the pulley problem. Okay, so that's why we just plug in 2 plus what is this m? This m is here. This m 1.5 kilogram. Okay, this might be a little bit tricky, but you have to be very careful when you plug in that m. Okay, so when you solve this, you get some answer. So I'm gonna use my calculator to solve this. Okay, so 14.7 minus 14.7 minus 10 divided by 0.5 into 2 plus 1.5, which is equal to 1.88. So 1.88 meter per second square. Okay, don't forget the unit. If you forget the unit, the professor going to take off 1 point, I think. It might be more, I don't know. Also, so we got the question B is here. We got it. We finished. And question C. Okay, starting from rest, very carefully reading. Fixed in the fixed if you're reading the problem solving is very carefully, okay, you have to be very careful. If you don't careful reading, it's going to change something, because physics is very unique, physics is very accurate. Okay, so how long does it take the block to move 30 centimeter? So we have to find time. How are we gonna find time? It's very easy. We use the kinematic equation. YF minus YI is equal to VIT plus half AD square. We have to remember. Okay, I think I already write it down here. That's not the kinematic linear equation. Okay, it's here. It's a linear equation. V final is equal to V initial plus AT. V final minus V initial is equal to V initial T plus half AT square. V final square minus V initial square is equal to 2A into V final minus V initial. That's a three kinematic linear equation. That's a rotational equation, kinematic equation. Okay, so we just plug in this number. So what is V final minus V initial is here, because the question is how long does it take move to 30 centimeter. So before we started, we have to change 30 centimeter to meter. To change 30 centimeter to meter, we have to divide it with 100. Okay, so is if you divide it 3, you got 0.3. Okay, it's divided by 100, so it's going to like 0.3 meter. Okay, it's that. So how long that is take move to move the 30 centimeters? So V final is this one. V initial is always 0. That's why we write 0.3 is equal to V initial. Velocity initial is here, starting from the rest, so there's no velocity. It's always constant. It's always 0. That's why it is 0 plus half A. What's it is here? We already find it. 1.88 into T squared. T squared we gotta find it. Okay. So when you solve this, 0.3 is equal to 1.88 half T squared. Okay. So if you find this, 1.88 divided by 2 is 0.92. So T squared is equal to 0.3 divided by 0.94. So 0.3 divided by 0.94 is 0.319. So it's the square root of so if we want T is equal to square root of 0.3, 0.94. The square root of divided by 0.3, 0.94 is 0.56. Okay, so 0.56 second. This time is second. Alright, so then we got time, and also this C. We finish all the question. This is a very good question. It's very a little bit tricky, as I told you, as I posted yesterday about like finding this one. By the time, here, problem 3. It's also like a little bit similar. Not very similar, it's a good question. This is still a really good question. It was the professor. Okay, so I'm going to show you what I did. That way you can see very clearly. Okay. Alright, if you have any question or any confusion, don't ask this to me. Ask Chat. The best way to ask is right now is ChatGPT or as your professor or tutor, whatever you would like, because I'm not a tutor or professor. I'm just helping you out to be a very easy way, easy method in your landscape. Okay, so alright, thank you for watching. See you in the next video.